The last of our short videos on DC circuits addresses RC circuits when we combine capacitors and resistors in the same circuit, and to think about what they get used for. Why do we care about tau and the other attributes of an RC circuit? Okay, why do we want to know what tau is? Why does it matter? Well, it can be a useful timing um, device. So you might think of a light flashing on a toy or something more serious like a pacemaker. If we know what RE is, we know what our voltage is, we can choose RC to determine how long it takes for the capacitor to reach a certain level, right? So let's look at this circuit at the right. And this is more like the kid's toy example, but we could see it in more serious applications. Like, let's say we have a light bulb here and we want to get this light bulb to kind of turn on and off. So in this circuit here, the light bulb has a really high resistance, but what distinguishes this resistor is that if I get a high enough voltage across here, basically the resistance breaks down and it's going to allow a current through there and become very low resistance. So initially, with the switch closed, I've got a 0 voltage everywhere, right? This is all ground. Um, and there's no current going through. So I switch this closed. And what happens? Well, this is high resistance, so no current wants to go through here. So the current wants to move here, and the capacitor begins to get charged. But I can control how fast it's being charged, right, by choosing this resistor and choosing my capacitor. As it gets charged, this has, let's say, use our example of 6 volts again. This has 6 volts. This has negative 6 volts. This initially has 0. It's going to get to, it's initially at 0. It's going to climb, right? It's going to get 0, 1, 2, 3, and it's going to climb up to 6. This, on the other hand, is going to go from 0 and it's going to creep down to negative 6, right? So we have, at some point, initially, the voltage here to here is 0 to 0. This is going to go up. This is going to go down. And let's say this resistor breaks down at 10 volts. Okay, so when this gets to 5 and this gets to negative 5, all of a sudden, current flows through here. Okay, and where does that current come from? It doesn't come from the battery because there's this big resistor here. It comes from the capacitor, right? You've got a big charge here and a negative charge here. So all of a sudden this flow is moving like that. Okay, it's discharging the capacitor very quickly, but it's lighting this up. As the capacitor discharges, it's going to lose some of its voltage, right? As the particles move all the way around the circuit. And then this is going to return to a high resistance, right? It's going to block that current. This is going to be mostly discharged, and then the battery is going to start charging it again. So you get a pattern that looks like this. Zoop. It reaches the threshold where that bulb allows a circuit or a current through, the voltage drops, climbs up again, it drops. And so you can create a device that you can time these peaks, which is pretty cool. So that's a more complicated circuit. The other use of an RC circuit and a capacitor in general is rapid discharge of energy, right? So we talked about this a little bit. A battery has a limited power. It has it has a high voltage, but it has trouble discharging very quickly. A capacitor can't store more energy than the battery has, but it can release that charge very quickly. So you charge your capacitor, you disconnect it, and all of a sudden you have a portable source of potentially very high energy, right? And so you can then connect this to some kind of electrical device and get a very quick release of that energy. And one of the key places where this is used in health sciences is a defibrillator, defibrillator, um, which I can't say, but I can show you a picture of, right? And so this is what, when you see like a portable one of these, I'm not going to say the word anymore. Um, when you see a portable one on the wall, it's been charged. It has a capacitor in it that has been charged or is being charged by a plug. And then you can remove that from the wall, and it can provide a really quick charge. So we can charge that capacitor. We can carry around this defibrillator, uh, and then we can use that to fix an arrhythmia in a heart, right? So if you have an irregular heartbeat, somebody having a heart attack, um, you can use this to apply large shocks um, uh, in an attempt to restore a normal heartbeat. So that's one really important use. So the two big uses of capacitors, or these RC circuits, are um, a quick charge of high energy and to use it in timing devices. And that is it for DC circuits.